Okay, we now have a product rule, so we're going to work through some examples so that you can see it in action. And this first one I'm actually going to do two ways. I'm going to do it with the product rule, and then I'm going to do it by multiplying it out first and not using a product rule. So those are both options, and you can pick and choose when you want to do one or the other for something like this. Okay, so first, if I'm going to do the product rule way, I do see that the big operation is a product right here, that multiplication. So I can say that f prime of t is the second times the derivative of the first. So I copy down the 1 plus 2t cubed exactly as it originally appeared. And then I multiply it by the derivative of 7 minus 3t, which is just negative 3. So it's basically a linear function with a slope of negative 3, which means its derivative is negative 3. And then I add the first, so I copy down 7 minus 3t exactly as it originally appeared, and I multiply by the derivative of the second. The second is a 1 plus 2t cubed. The derivative of 1 is 0, so I'm really just looking at the 2t cubed. When I drop that 3 down, I'll get 6t squared. And then you should simplify your answers, so I'm going to go ahead and distribute this through. And I'm going to distribute the 6t squared through, and I end up with f prime is equal to negative 3 minus 6t cubed, and then plus 42t squared minus 18t cubed. And then I can actually go one more step because I ended up with 2t cubed terms, so I can combine like terms, and my final answer will be negative 3 plus 42t squared, and then it's minus 24t cubed. Okay, so that is with the product rule. If I want to do this one without using the product rule, and I just want to be clear, you can't always rewrite things so that you don't have to use the product rule. It's just because this is a polynomial times a polynomial that I have both options. So to do it without the product rule, you would FOIL it out first thing. So this is not derivative, this is just original function, and I'm FOILing it out. So I get a 7 times 1. My outside is 7 times 2t cubed, so it's positive 14t cubed. My inside is minus 3t, and my last is negative 3t plus 2t cubed, so negative 6t to the 4th. Okay, so now that I've multiplied it out, I can take the derivative. So this is the first actual calculus step here. The derivative of 7 is 0. For 14t cubed, I drop that 3 down, and 3 times 14 is 42, and now I have a t squared. The derivative of 3t is just 3, and the derivative of 6t to the 4th is 24t cubed. And if we compare, both have the minus 3, both have the 42t squared, and both have the negative 24t cubed, we do in fact get the exact same thing. So honestly, I think that multiplying it out first is a little easier, a little bit less work, but neither one is very hard. So it doesn't matter. You can use either way. You do want to end up with a simplified answer. So don't just set up a product rule and then leave that. Make sure you multiply out and clean it up a little bit. Okay, let's try another one. This is a good example of a problem where you don't have the option of multiplying it out to get rid of the product rule. You could distribute this e to the z in, but then you would have two product rules because you'd have e to the z times z to the negative 11, and that would require a product rule. And then you would have e to the z times 58z, and that would require a product rule. Because one of the factors is exponential, we can't just multiply and combine it with the others. So I'm just going to leave it how it is, but if you wanted to distribute first, I think you'll get the exact same amount of work, just in a slightly different order. So whatever you prefer there. The e to the z is my first, and the parentheses, the stuff in parentheses, is my second. So if I want dy dz, and keep paying attention to that notation, that means y is my function, and z is the variable I'm taking the derivative with respect to. So I need the second exactly as it originally appeared, multiplied by the derivative of the first. The derivative of e to the z is still e to the z, so that I can actually leave just like that. And then I want the first, e to the z, exactly as it originally appeared, times the derivative of the second. So now I'm taking the derivative of everything in parentheses. The big operation there is the sum. So we'll look at the z to the negative 11 first. That is a power function. The variable is the base. So we will use a power rule, drop down the negative 11, get z to the negative root 11 minus 1. And then plus the derivative of 58z, which is just 58. So I would say two options on the simplify here. One is just to distribute the e's through both sets of parentheses and call it good. The other option is you could factor out the e and kind of pay attention. Your homework problems for this section should have some specific directions for how you write your answer, because these problems are set to not just take the product rule unsimplified. So if I want to distribute it all the way in, I would get z to the negative root 11 times e to the z, and then a 58z e to the z. And over here, second set of parentheses, I'd get negative, so here let's just make it a minus, root 11, z to the negative root 11 minus 1, and then e to the z, plus 58 e to the z. And it's still a mess, right? It's not necessarily neater looking, but having things in this weird partially factored form where the big operation is addition, but then the terms are factored, that is not helpful for just about any situation that I can think of. So either fully factored or fully multiplied out, and what you're looking at here is fully multiplied out. Fully factored would be to remove the e to the z from all four terms and have it factored out in front. Okay. One more, just practicing derivatives. Let's get a trig function in the mix. So the multiplication is the big operation. This is 3 to the x times cosine x. So if I want dw dx, I'm going to take my second, cosine x, and multiply it by the derivative of my first. 3 to the x is exponential, so its shortcut will be 3 to the x times the natural log of your base, natural log 3. And then, so what did I do? Second times the derivative of the first. I need the first times the derivative of the second. The derivative of cosine is minus sine, so I'm going to switch that to a minus sine x. There's not really a ton that needs to happen here in terms of simplify. I think you could enter this one just as it is. There's no weird needing to distribute. You could rearrange the order of terms, but that won't matter. Just to show it, you could absolutely factor out a 3 to the x. This is something we'll want to do later, is work on factoring these things. So it's not a bad thing to look at right now. So that is something that you could do, but I think a lot of these will ask you to give the answer fully multiplied out. Okay, so hopefully that gets you started on using that product rule.